So I'm going to finish all the Excel demonstration in just one video. Since these are not very complicated, I think one should be enough. Okay. I think you need to finish the first one because it shows how to plot a control chart in Excel. Okay. I'll be plotting the whole full complete control chart for dataset 1. Okay. For other data sets, I'll be just calculating the upper and lower control limit. Okay, so always I think it is important for you to write down all the key parameters before you continue. So here K, we have 25, right? For N, we have 100 because sample size is 100, right? And P bar is going to be the sum of all the defects, right? And divided by the sum of all the samples. Okay, if you compare this formula with your the math formula, it basically says the same thing, except that for denominator, I'm just simply using the range instead of 100 multiplied by 25. Okay, so this is the average proportion of defects. So let's calculate proportion defects for each sample. So it's going to be number of defects divided by number of the sample size. So this is the per sample defect rates, defect proportion. We are identifying the appropriate upper control limit and lower control limit in order to determine whether these sample proportions are indicating any underlying process out of control. Okay, so for the upper control, we can't actually do that right away because we need to calculate the standard error, right? Standard error is square root of P bar multiply 1 minus P bar, right, divided by the sample size N. Let me see. I need to close the parenthesis before I do division. Okay, this will give me standard error of 0.01467. And then upper control limit is very simple. Plus 3 multiply the standard error. Okay, the lower control limit is going to be the maximum between minus 3 multiply standard error, right, or 0, whichever is greater. So as you can see, it must give you a negative number, therefore we're taking 0 as the lower control limit because proportion can never go below 0. That is the case. And how do you plot it? How do you plot something like in your book in Excel, right? Something like your book, like this one right here. How do you plot it? So for that, you need to put down all your numbers here. Instead of calling P bar, just call it center line. Okay, and then UCL, LCL. So center line with absolute reference, lower control is going to be it's upper control F4, lower control 0 F4, and then we double click, and with this ready, we are ready to draw the control chart. I'm going to highlight column A. Okay, press Control key. Let me do it again. After you highlight column A and column A only, once you release the mouse button and then press down your Control key, and then start to highlight proportion all the way to the lower control limit column. Okay, so you are highlighting two areas that are not right next to each other. And then with that, we're inserting the plot. Okay, so as you can see, you can almost see the shape here. But this is not quite what we want. Go into all charts, go to the line with this marker, right? Go to the second one, okay, that will give you a proper control chart. Okay, so change its name to PBar chart or P chart for error scanning. So this can tell you intuitively whether this process is in control or not. You can see the center line here is in orange color, and the upper control limit is in gray color, and the yellow color is the lower control limit, and your actual proportion is using the blue dot right here. It looks like the process is is in pretty good control here. Let me see what happened here. 3 and 4. 3 and 4 are both 0, so it did not go below the lower control limit. So by looking at it, every observation here indicates that process is within good control. Okay, so with that, I'm going to move on to the next one. Again, in the PBar chart series, we only need to plot one control chart. It's not like in X-bar, the variable measurement, you have to plot both standard deviation, both the variation and average. So in this case, one chart is enough. Okay, so for the upcoming examples, I will not plotting the control chart. I'll be just simply calculating all the center line and the upper and lower control limits, and it is up to you to plot them in Excel if it's necessary. Okay, this is one skill you need to master. So let's move on. So let's continue to take a look. It looks like it is a P chart with various sample size. Okay. Oh, I may need to show you how to draw control chart on this one too. Even though I said I'm not going to do it, but just for demonstration purpose, because it's using various control limits. Anyway, let's first write down all the keys, right? All the keys here. We have K as 20. We have 20 observations here, but we don't have constant n, so we can only calculate average n, which is the average of n. Okay, so with this ready, let's find out the P-bar, average proportion. So the calculation is the same. You're basically summing up all the defects divided by all the sample size added together. This is your P-bar, which is also your center line. And what is the standard error? So because, you know what, because it's using the various control limit, therefore we need to calculate the standard error for each sample size. So what I'm going to do, I'm going to say the center line is going to be the P-bar here. And then I'm going to do the absolute reference. And for the standard error, what I'm going to do is square root of center line, which is also our average proportion, minus, then divided by the sample size, and in here. What is D4 here? To move D4 out. Let me do it again. Okay, I'm sorry. Square root multiply 1 minus P divided by sample size n. So this is a standard deviation for this particular group, okay? And then your upper control limit and lower control limit is also different for each case. So upper control limit is center line plus 3 standard error. Okay, for lower control limit, it's going to be the maximum of your average minus 3 standard deviation or 3 standard error, 0, whichever is greater. So with this thing set up, I think I can just double click. Voila, you have completed everything you need to construct a PBar chart. Various sample size. Highlight column A and press down your control key. Highlight D to G column and insert and C. Okay. See, may have made some mistake in here. I don't know why it doesn't like me. So let's take a look. Let's draw this thing right here. Okay. Let's see whether this thing makes sense or not. This thing makes sense other than we have included things that we should not have included. And we did not include things we should have included. Okay, so for that reason, let me go back and modify a little bit. I think I missed a critical component here, which is a proportion. Okay, so proportion is, proportion is a value, must be a whole number. What's going on? So let me do it again. Divided by this. Okay. That. Okay, let's try it again one more time. It's good exercise. I highlight first, column A, and proportion, center line, here. Okay, lower and upper. So as I highlight those data, I'm continue to press down my control key so that I can actually highlight data that are not in the same area. Okay, with that, insert, and looks like we're getting the set. We're getting there. The number 4 and second. This is what it is. Okay, it uses various control limit. As you can see, that control limit is different from sample to sample, and this is our center line, and the blue indicates the actual proportion observed, and it looks like in the 15 it went out of control in here. We need to identify what happened in 15. I mean, that is more managerial problem, but I think we can move on. So for those of you, if you're wondering how to plot this case, average sample size approach, I think in this case, you know, things will not be that different. Okay, it'll be much like the previous case where they share the common center line, common upper and lower control. You just use the sample size and bar. Okay, there are some requirements as to which sample group can use average sample size to represent original sample size. For that, you can go back to the slides to refer that information. It has to be fall in certain range. Okay, so I'm gonna move on to NP chart. So with NP chart, remember that we are plotting what? We are plotting the control chart based on the count number of errors. Okay, so for that, I'm going to write down the key information first. K is what? K is here 25 observations. In each observation, you have sample size of 100. How do you know it? It's right here, sample size n. Okay. With K and n here, you first calculate the proportion P bar. Okay, proportion P bar. Which you can follow the previous approach, or you can follow easier approach. With K and N error, with K and N ready, what you can do here is to calculate MP bar first. Okay, MP bar is nothing but sum of all the errors divided by the number of samples, which is 25. Okay, you also need to know the P bar. So P bar is nothing but MP bar divided by N. Okay, MP bar divided by N. So our center line is MP bar, and our standard error is going to be square root of MP bar multiply 1 minus P bar. Okay, so this is our standard error, and with that you can construct a control limit. So UCL, LCL is going to be center line plus 3 multiplied by the standard error, and lower control limit is the center line minus 3 standard error. Boom. As you can see, this is negative, but the count cannot be negative. Therefore, you also need to use maximum and 0 in here. Yes, I did not indicate it here because I refer to the textbook, but that is a pretty common sense thing. The count can never go below 0. So this is your lower control limit. So if you want to plot it, you can always use the previous approach, putting things here and doing this, using this data. Center line. You don't need standard error for plotting. Upper control, lower control limit, and it's equal to 2.2. Absolute reference equal to upper control absolute reference equal to 0 absolute reference, and you're ready for the control chart. Okay, for the C chart, let's move on. So with the C chart, things are relatively simple, I think. The key here is K. You need K is 25. You don't need sample size. You only need to know number of errors. So we do the C bar, which is your center line. It's the sum of all the error you divided by the K. Okay, so the average error is 1.8 in each sample. And your standard error here is square root of this guy. Okay, and then you can use that to construct your upper and lower control limit. Upper control, lower control limit, and it's C bar plus 3 multiply with the standard error, and it's going to be the maximum of center line minus 3 multiplied by standard error, or 0, whichever is greater. So with this, you should be ready to construct a control limit, and then to determine whether the process is in control or out of control. Last one, PBar chart. The last case is PBar chart, and let's find out the important information first. So this case, you know that we are looking for a various control limit. Therefore, control limit is different from the sample group to sample group. Therefore, it is necessary for us to write down some information next to the each row. But before that, let's calculate the center line first. U bar is going to be the sum of all the nonconformances divided by sum of all the sample sizes or sample opportunities. Okay, so it looks like the number of nonconformances is quite small. Okay, with that ready, what we're going to do is we're going to calculate. Okay. We're ready to calculate the defect per unit. Okay, defect per unit. It will give you 8/92. Okay, so this is the number of defects per sample unit. With that, let's plot the center line first. Okay, center line here is U bar F4. Okay, and then you plot the standard error. Standard error, it will be square root of the center line U bar divided by the sample size, which is 92 here. Okay, so then let's do the lower control limit and the upper control limit. It's going to be the U bar minus 3 standard error. Okay, or should we do maximum of 0 or that? The upper control limit, center line, plus 3 multiplied by the standard error. The sample size is different from sample to sample, so you will see standard error is different from sample to sample. Therefore, you see the different control limits from sample to sample. The double click. Okay, yeah. With this, you have all the numbers you need to construct a control chart. Let's plot it for this case, okay? Because it's a various sample size. Do it. You are comparing column D against the limits, right? This is your center line and G column and H column together. We insert it. Okay, all charts, lines, for here. So with that, you can see our control limit is different from sample to sample. Initially, it looks like sample number 2 has abnormally high defect per unit. We need to investigate what actually happened in here. Okay, so that concludes every demonstration we need for this last component. You just need to be careful to determine what type of charts does it follow. Okay, then need to apply the right rules to calculate the center line and the upper and lower control limits.